Metacentre is usually considered as a measurement of stability of a floating body. Hence, it is a very important concept while designing ships. Let us consider a body floating on a water. As we know, body floats on water because their mass density is lower than mass density of the fluid. Wood, plastic, and ice cubes are examples wherein densities of floating bodies are lower than density of fluid. A body also floats on water when the weight of the fluid displaced by the immersed body is equal to the weight of the body, as in the case of boats and ships, etc. As in case of ships, two types of forces acts on it. First is vertical downward force of gravity, which is equal to the weight of the body, which acts at the center of gravity of a body g. Another force which acts on the ship is buoyant force, which acts due to the force exerted by fluid on the ship. The buoyant force F is equal to the weight of the water displaced by an immersed body. This buoyant force passes from the centroid of the displaced volume of water, which is also called as center of buoyancy B. Now, for a ship to be in equilibrium, buoyant force must be equal to the weight of the body, and also point of center of gravity and center of buoyancy should lie on the same vertical line. When the ship tilts in the right direction, the volume displaced in the right direction is larger as compared to the left direction. Due to this, the center of buoyancy shifts in the right direction, from point B to B'. Due to large volume of water, more force is applied, resulting in the formation of couple. The point of intersection of the vertical line through the new center of buoyancy, B', and the center line BG is termed as the metacentre of the body. The distance between metacentre point and center of gravity is known as the metacentric height. We can also write metacentric height as Gm is equal to Bm minus Bg. Floating bodies possess three types of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. When metacentre M is above the center of gravity G, this is called as stable equilibrium. In this case, a restoring couple is formed by the buoyancy force and weight of the body, which tends to turn the body into their original position. Now, when metacentre point is below center of gravity G, the overturning couple forms by buoyant force and weight of the body, which tends to sink the body from its original position. Thus, the body is said to be in unstable equilibrium. When metacentre point M coincides with center of gravity G, weight of the body and buoyant force becomes collinear and passes through same line of action, due to which the body neither returns to its original position nor increases its displacement, it remains in that tilted position. Thus, this body is said to be in neutral equilibrium. This is typically used while designing ships. Higher the metacentric height, higher the stability. But, if metacentric height is kept too large, it will tend to continuous oscillations, resulting in discomfort to passengers. Hence, passenger ships have lower metacentric height as compared to warships and rafting boats.